Hello, dear students. Let me introduce myself. Tashkent Institute of Irrigation and Agriculture Mechanization Engineers, OZODOV EZOZ, and today I want to talk about the most exciting and interesting theme in automation, about the signals, the types of signals, and where they use, and why they are so important in our technology process. But first of all, to understand this theme, to make a good introduction, let's make a little experiment. How you understand that I make a clap? Of course, you see with your eyes in visual and understand that I make with my hands this movement. And then you hear with your ears this sound. But what else if I told you that everything which you see and hear is the signals? Without signal, your mind never understand that I make a clap. So your whole body move in according of the signals. Your hands, how your heart is beating, how your breath, all of them is based on the signals. And the technology process is the same. To control the technology process, to make good results, and to take serially numbers and a quantity, you need serially signals. But if you don't know the basis of signals, you never understand that it's important and necessary, and you never can make a good control system. So let's start. First of all, I hope that after this lecture, you will understand the types of signals, where they use, and the mathematical explanation of the signals, all the types of examples where we can use the signals. Okay, let's start. What is the signals? Signal is a codified type of information. And according to this information, we can change it, convert it, and take new results. And we can change the serially values which we need. And according to all the actions which we have in physical type, we can convert it to the real normal form. So this is a signal. And you can say that people's is different, technology process is different. Are we have any types of signals or classification? I told you, yes, we have a special classification of signals. According to their functional work, signals have two types. First of all is analogous signals. And the second one is digital signals. And today I will explain you which different they have. But to understand how they really work and why we need to know analogous signals and digital signals, let me show you one interesting electrostatic set. Here, I told, and all the frequency became a light. My claps, all of my movement, which according to frequency of the air became information, became a signal. And then I take this result, like a lamp. So this lamp is result. As you know now, as you understand, that signal is a transformer of action to result. Without signal, we never have any result. Like your message in your mobile phone, all of them is based on signals. In analogy or digital, it doesn't have matter. Okay, first, let's talk about the analogous signals. Analogous signals is a continuous process of frequency of electrical energy in one line in a one time period, and it's have a very continuously process, and in any time of work process, it will have a top point and maximal value and a low point, this low point value. And this is have a negative effect to systems. So in the process of production, people try to minimize these actions, this negative effects. And then people invite the digital signals. And here you have some graphic. In this graphic, as you know, we have a very extremely changing frequency. And this points is very fast to change. So it have a big problem that you can take information with a high quality, and information will be lost or stolen, or in a difficult type of elements have some changes. So it's an easy side of this signal. But how we can explain it? How we can know we have analogous signal? Here we have a special mathematical explanation in according to function in a time period. It's going with a change. So in this mathematical function, it's all explained. And if we can count the certainly time of work, this process signal, we will put the value. But if we don't have a time, how long it will work, we can put the normal value of the information to analogous signal. To understand analogous signal well, let's make a little illustration. Here you see the time, yeah? Time is never come back again. And analogous signal, same. If analogous signal start to go and give information, if we stop this process, it never continue from that point which end. It will start from 0 point. It means that we can repeat this information. And all of them is continuously go. So you can say me, why it's important, why we use if it's have so lot problems. As I know, you heard, yeah, you see, all the processes analogy, it's continuously. To detect the signals, we need analogy type. Without analogy type, we can detect the signals, and we can make reaction, solve the problem of technology process. So in this sphere, analogy signal is important. But don't need to forget about the digital signals. They have a very good opportunity, and now we use these signals in your cellular, in your laptop, everything, in all systems which have account, they take a digital signal. So what is the digital signal? Digital signal is an analogous signal in approximation form, which gives its value in certainly time. According to this approximation, we take a certainly number, 0 or 1. 0 or 1. And according to this combination, 0, 1, 0, 1, you take a numerical information. It could be like a sound, it could be like a media information, like image or movie. Everything is based on this 0 and 1. How you call to your friends to know how they are, the signals is transformed to these numerical signals and then became a noise. All the signals have their opposite working. This opposite is a noise. When we have a noise, we try to filtrate and take information from this noise. And this process of taking this information is called analyze. We analyze the signals. And according to this analyze, we take a solve. This solve will be reaction. About the mathematical explanation, everything must be explained certainly. So let's talk about the mathematical explanation of digital signals. Here we have a good equivalence that certainly explain it. What is the digital signal? Here you can see that we have a period of work, this signal. We have a time of this approximation, and we have a value of this approximation. Here everything is shown. In Q equal, we see the cycle, and according to this is a cycle, we have some numbers. All the numbers is talk about the period, approximation, and a time. If we put our numbers, we'll take a digital signal. It's very easy, yeah? So, what's the difference between digital and analogous signal? Let's see this illustration. Here you see the person. In the left side, you have a mountain. In the right side, you have stairs. And I want to give you a question. Which one is easy to move? Very easy to move. Climb to mountain or move with the stairs? Of course, moving with the stairs is easier. And here, mountain is analogous signals, and stairs is digital signal. You certainly know how much time you need to go the stairs to take your result. But unfortunately, in mountain, you don't know how long it will be continue. So we have a little conclusion that the digital signals have a good quality. So they're important. And you can say that if I have an analogous signal, can I transform it to a digital signal? And I will answer you, yes. And in this slide, in this illustration, you can see the process of changing analogous signal to digital signal. As I told you, if we take an analogous signal and then make approximation and put value to the per second of moving this signal, you will take a digital signal. To take this digital signal, you will use a special set, which call it the changer, analog digital changer, ADC. And this set help you to take analogous signal to digital signal. Like a pressure, temperature, and moving, lightness, all of them is a physical actions. And physical actions, of course, is analogous signal. And if you want to show it in a numerical form, You need a digital signal. And here, this ADC sets help you to take this signal and make accounts which you need, and a measurement and all the processes which among the going to in your technology process. So, how it's happened? Let's see the mathematical explanation of changing analogous signal to digital signal. Here, yeah, we have equivalence. Yeah, right side you have this ADC changer, and in the left side the graphic how it changed. In a blue line, show this analog signal. In a red line, digital signal. How it's changed? You see, analog signal is a come, and in the crayons of the signal, put the stairs, certainly stairs of approximation, and it became 0 or 1. 0 or 1. Again, it's became information. And what the rule they use, what the terms of changing analogous signal to digital signal. Here you have a special streams and numbers. Yeah. Here first of them is Q1. This Q1 is a process of changing analogous signal. And here the first value which we need to expect is the time. Time and then the power of the signal. Power and the time. According to them, we can change them to a numerical form. Okay, let's make a little conclusion to analogy and digital signal, their advantages and disadvantages. Yeah, advantage of the digital signal. Digital signals are very certainly, they have a good quality. They can use in programmatic language. They can use in a sets of measurement. And most important that we can give this information in a long distance. And here we can make a remote control. Yeah, as you right here, digital signal is the answer to remote control. An example of use, where we can use this analogous signal and digital signal. First, which you can see here, it's a measurement, high frequency water level measurement sensor. It's a take, as I told you, frequency. Frequency is analogous signal, but the result will become a digital signal, again with the ADC changer. And we can use the sensor to know the level of water in any place which you want. In a pump stations, in a water dam, it doesn't have matter. You just need to know right signal to use this special set. And next one. Next one, oh, it's very awesome. Here we have an image of picture of my institute. And all of you use social media networks and social networks and send to your friends a picture, but you never give a question how it became. It's again a numerical signal. It's a digital signal. But how it's transformed. When you take a picture, it's make a code of 1 and 0 combination, and a special filter of Bayer, it's becoming information. Here you see the picture of my institute. It's very beautiful. And filter of Bayer. And result. It's amazing, yeah? Just a simple points of numbers became an image. And the signal gives the chance to you transform this image in a remote, in a long distance. And the second one, yeah, it's a full form of picture. Here you can see the green and black points, but for sets for technology, for digital technology, it's information. And this is one was the last information which I told you, but don't forget about the homework. And at home you will do, first, make a SWOT analysis, SWOT analysis of analogy and digital signals. Make your own example. And this is the last information which I want to give you. It was very exciting to give you this information. I hope I don't say goodbye. See you. Thank you for your attention.